Hi, this is Kevin Trainer, and I'd like to welcome you to my tutorial demo for Chapter 7 of Murach's MySQL second edition. And this is a chapter on subqueries, and so we're going to be exploring subqueries. In fact, you can see a list of subqueries that I have created using the My Guitar Shop database, which is what I'm expecting you to use in the exercises that you're doing, that use subqueries. So let's open up MySQL Workbench and get a connection fired up. And when I'm working with a test database like My Guitar Shop, I tend to keep a copy of it handy, the script that recreates it, because I always want to make sure I have a fresh copy. Okay, if in fact that's what I need for the current operation, but I want a fresh copy now. I'm just going to run that script. And as you can see, the schema disappears over in the navigator panel. And when I refresh it, it shows up again. Okay? So let's go and get the first query that I have, where I'm using a subquery, and I've already demoed this in a prior chapter. It's just a way to avoid having to code, having hard-coded primary key values or foreign key values in the where clause. So let's just open up that. And here we go. So we're saying use My Guitar Shop. I consider that to be the best practice. Select all columns from products where category ID equal. And now, instead of hard coding the category ID for guitars, I have a select. So the select says select a category ID from categories where category name equal guitars. Okay, so that is just a subquery to avoid a hard-coded value, common use case. And when I run that, I get all the guitars that are in the database. I see it returns 6 rows. I want to emphasize that I do have an order by clause here, okay? And it may be that even without that order by clause, it would come out in the same order. In fact, let's just see what that looks like. Let's delete that and run the query again. And it does, in MySQL, this particular implementation, it does come out in the same order. I'm going to undo that change. But this isn't reliable from product to product, and perhaps even implementation to implementation, version to version. So you can't rely on it. So I always want to see you use an order by clause in these circumstances. So again, when we run this, we get them in the right order, product ID order. Okay? And this is a classic case where in the where clause I'm saying category ID equal, and I'm doing a select, and we usually think of a select bringing back a result set, which would have columns and rows. Well, most of these subqueries that we're going to be doing are only bringing back a single column, in this case, category ID. And in this case, we are only bringing back a single row. So we're really only bringing back one value. And when you see how that fits into the where clause, where category ID equals whatever the value of category ID is for guitars, well then we're bringing back just what we want. So in this really simple case, we're not only expecting to get back only one column, we're also expecting to get back only a single row. Okay? So that's probably the easiest use of a subquery that we have. So let's go look at what some more would look like. How about if we wanted to do something similar to what we did, but we'd like the query to be a bit more complex. Okay, so for instance, what if we want to return more than one row in the subquery? Okay, well then a change that we need to make is that we don't want to say equal. We don't want to say equal more than one value, okay? Because syntactically that really doesn't make sense. So then we switch to the in operator. So if our subquery is going to return more than one row, and if the test is it can be any of the values, it can match any of the rows, then we want to use the in operator. So again, the result set of the subquery is returning one column, the category ID column, but more than one row. In fact, we're going to return the row where category name equals guitars and the row where category name equals drums, and we get that by coding an OR here, okay? So we're returning two rows, okay? And when we run this, sorry, I selected the OR. When we run this, we get 8 rows returned altogether, and as you can see, we are getting the guitars and the drums. So these are guitars up at the top and drums at the bottom because that's where they happen to be in the product ID sequence. And again, it's very important to remember that we want an order by. Okay, we want things to come out in a reliable order, even though you could maybe get away with it without having it in MySQL. It's not a good practice to come to rely on that. Okay? So that's how we would use the in operator. So now we've used the equal operator, we've used the in operator. All right, let's try some more stuff. How about we use not in? Okay. What does this look like? I'm sorry. That's not the one that I wanted. That is not the not in. There'll be a slight pause. Okay, I fixed that. Apologize for that. So here is just really the opposite of the query that we just saw. So we have the same subselect. Okay, so we want to select category ID from categories where category names equal to either guitar or drums. That is going to give us 2 rows. But the operator that we're using instead of in is not in. So we're going to get everything that doesn't match these 2 rows. So let's see what that's going to look like. All right. So we've just got 2 products that are not guitars or drums. And I know they look like they're guitars, and that's because they're bass guitars. So in this way of looking at products, they're not guitars, they're basses. Okay, very good. Let's move on. Okay, so let's explore the use of some, any, and all. Now, the first thing we're going to look at is sum. And I just want to point out that sum is part of the SQL standard, okay? And it's also the equivalent of any. So sum and any are synonyms. And the best explanation I have for why we have both the sum keyword and the any keyword both is that early versions of SQL didn't include this, and sum and any were two vendor extensions from very popular vendors. And so when they agreed upon the standard, they brought them both in as synonyms because they couldn't agree that one of them would have to make their users go back and change their code. Okay, so sum and any are synonyms. Our textbook shows you that there's a sum, but then doesn't provide a whole lot of examples of sum, and that's because sum and any are the same. So let's look at sum. So here we want to list all the products where the list price is greater than some product in category 2. All right, let's look at this. We get 6 rows returned. Okay, and again, I ordered them by product ID. Even if they had come out in the right order, I want to make sure that it's under control. And you'll notice that my copy of SQL Workbench, it doesn't like the word sum. Okay, so it doesn't really want to support it, although the server interpreted sum very accurately. So if I am correct and sum and any are synonyms, the next query that we're going to do, which is going to use an any expression, should get the same answer. So here we've got 6 rows returned. Let's open the next one. Which uses the any. And let's run that. And very nicely, we got the same 6 rows returned. Okay, so these are products that have a list price that's greater than any product that's a base. Okay? And I just want to point out, if we had wanted to, we could have had a sub query and avoid hard coding category ID equals 2 by going and figuring out which category ID was the category ID for, now I forget what it is. It's probably basis. Yep. Nope. I forget what category 2 is. These are guitars. These are basses. What is category 2? Let's look. Category 2 is basses. All right. Let's go back. And there we are. Okay, so you know, I really don't like this answer because we're getting a base in this. Oh, no, that's fine. You know what? The more you look at this, the more you... So this, there are 2 bases, right? And this is the more expensive one. So it is, has a list price that's greater than the less expensive base. So this is appropriately in the answer set. Very tricky. I love that. Okay, let's look at the next one. So we've been able to demonstrate that some and any are synonyms. Any is probably the more popular term. Okay. And then let's look at all. Okay. Here we want a pretty much the same list, but we want the list price to be greater than all of the products in category 2, which is again the basis. So this time we should expect to get a similar list, but we don't expect to get any bases because we don't expect either of the two bases to have a list price greater than themselves. So let's look at what we got. We only get 2 rows returned, and neither of those is a base. So that's a reasonable answer. Definitely a reasonable answer. Okay, let's go do some more stuff. What else could we do of this variety? Well, let's use a correlated subquery. Okay, what's that? Okay, well, here we're going to list all the columns for products where the list price is less than the average of the list price for that product's category. So the subquery has to be evaluated for each product. This is what we call a correlated subquery. Right? So the first of the products, let's say, is the guitar. So then in the subquery, we come up with the average list price for guitars, and then we compare the list price of the guitar row we're on right now to the average. And then we come to the next row. Okay, and then we might come to, eventually we would come to a base. And then we'd have to create the subquery again because we'd have to get the average list price for a base. And then we'd have to compare those. So when we run this, we have a list of all the products, 8 of them, that are, and we didn't do more expensive because that gave us a very small list, so I did less expensive than the average. And this has to do with the fact that we have a couple of real high value items, and they skew the average high. And so there are very few things that are greater than the average in those categories. So I turned it around and I said less than the average. So we'd actually see some real data. All right. So that's that one there, the use of a correlated subquery. Now, something that does something pretty close here is the use of the exists and the not exists operator. So let's look at exists first. Okay. So let's see. We are selecting all from category where exists. Select all from products where the product category ID and the category ID are equal. Okay, so let's see what we get here. Well, let's see. So we've got guitars, basses, and drums. I remember there was just one more category that was keyboards. Okay. But keyboards didn't have any products. Okay. So we're not going to get a match between the categories and the product, so we're not going to get that row. But we did get a match on the other 3. Okay? And again, this is a correlated subquery because it has to be evaluated for each row in the outside query. So we come to a category, right? And then we have to go do a subquery of the products for that category. Okay? And we have to see if we get any products for that category. So when we asked if exists, we typically don't have to control the number of columns that we get back. What's really significant when we're using exists or not exists is how many rows we get back in the result set for the subquery. Okay, and so if we get at least one row back, exists is true. If we don't get any rows back, exists is false. So here, this means that we get a row for guitars, one for basses, one for drums. We don't get any for keyboards. Now, if we turn this query around and use not exists, I would expect to see the keyboards and not see the three that we see now. Let's see what we get. See, we just have not exists. Everything else is the same. Give it a run. There's your keyboards. Okay? And why was not exists true in this case? Because we got 4 keyboards. The correlated subquery, the subquery that we did for keyboards, brought back no rows. So not exists. Okay? Okay, so we've seen the use of a subquery in a lot of places, but so far we haven't used it in a from clause. And we're going to do that in a minute. And when we do that, we create something we call an inline view. So one of the nice things about the relational database architecture is that the results of selects are tables. They're result sets, and result sets are tables. So instead of querying a proper table from the database, one of the so-called base tables, we can, in its place, we can query the result set from a select. Well, that seems like a lot of work. Why might we want to do that? Well, you might want to do it if the select that's the subquery is pretty thorny in its own right, because then the outer select becomes very straightforward. Okay, so here what I'm doing is I have a select in which I'm trying to come up with the first name of the customer, their email address, and the category name, okay, based upon everything that a customer bought. So I want the distinct ones. I don't want any duplicates. What I'm trying to do is create mailing list information. Okay? So what I want to be able to do is I want to be able to go through the results of this query, which would have every email that I might want to send out. And what I want to do is I want to be able to look through and say, okay, for guitars, I want you to show me all the rows. So with the email address and the first name, I would be able to write a program to send some junk mail saying we're having a sale on guitars. Likewise, I might want to do that for drums or for basses or for keyboards. Okay? So that's what this is going to do. In order to do it, to get this data, I need to join customers in order to get the first name and the email address, with orders, because I have to go through and to connect to order items. The only way to join between customer and order items is to go across orders. And then from order items, I have to go across to products. And then from products, I need to go over to categories. So to get this simple result set table that's going to be really easy to query for mailing lists, I have to join 1, 2, 3, 4, 5 tables. So 5 tables, 4 joins. Okay? So if I do this and I think of this as my mailing list, well then what would the query look like that uses this as a subquery? Well, here's the query that would bring back the mailing list for drums. Okay, so what do I want on in my result set? Well, I just want the first name and the email address. That's all I need to give. I give that result set to my program code that's going to send out my junk mail and my junk email. And I'm going to be able to not only send it to the right person, but I'm going to be able to say, "Dear Kevin, you'll be excited to know that basses are on sale at my guitar shop, blah, blah, blah." Okay? And it's going to be important to them because we know they bought a bass already. Okay? Now, you might question the wisdom there. If we're selling to individuals, maybe if we already sold them a bass, we don't want to sell them another bass. But you could, you could decide what your criteria were. All right. Okay, and then so the from just includes that select that we just had that I said was the overall mailing list with all the data on it. It also has a table alias. Okay, I just want to point out that it does because at least in MySQL, it won't work without the table alias. Okay, so we want to select these things from this inline view, as we call it, where category names equal to drums. And then, of course, we need to impose some sort of order by email address. So what does that look like? Well, we're just sending out emails to 2 people about our drum specials. So you might say, okay, that's good. Well, what if I wanted to do that all the time? Well, although it's not officially covered in Chapter 7, we can take these inline views and simply with a little bit of extra code, turn them into a view object in the database. So what does that look like? Well, syntax is pretty clear. Here's a formal declaration for the mailing list view. And again, we're not going to, we're all going to see this pretty soon. So the select, character for character, the same. So what do we add? Well, we say create view, then we give it a name as, that's all we have. So we're creating a view we call mailing list, okay? And mailing list becomes like a table. I just want to say this about views, though. They are temporary tables, okay? There are some features in some relational database management systems like Oracle, which give you the possibility of creating a view in which it saves the data and and it maintains it. It's called a materialized view, but this is not a cross product feature. So a standard view is we run the query, we run the subquery that creates the view. We run it every time we reference the view. So you always get a fresh answer. So once we declare this and run it, so we're going to run it here, and that's actually going to add it. I just want to show you, if we look over here on schemas, you see that we don't have any views. We have tables, right? But we don't have any views. Now let's run this. Okay, and it ran. Create view was successful. Now let's come over to this panel and let's do a refresh all. And we'll see we have a view, and it's called mailing list. And let's look at the definition. Well, let's just look at the data. Here are all the data. Okay, now every time we refer to the view, it runs the query that sits underneath it. It doesn't save these data. Okay, always happens on a dynamic basis. Okay, so if we go back and use this view in a query like the guitar, like the mailing list that we put together for drums, what would that look like? Well, so we have the same things. Select first name, email address from, and we just use the view name. Okay, where category equal drums. So let's give this a run. And there it is. Pretty nice. So that is it. Okay. So we're going to learn more about views, or we're going to review it again when we get a couple of chapters down the road. But again, the use case is we would like to be able to do simple queries by hiding the complexity in a more complex query that we don't have to think about all the time. And we can call it something like mailing list. And there's, what? Was that mailing list? Here's the formal declaration right here. Okay, so we're joining 6 tables, I think. Is it? No, 1, 2, 3, 4, 5. I don't know why I claimed 5 before, but we're joining 5 tables with 4 joins. So that's plenty of joining right there. And probably a little too complex to be thinking about every time you want to pull a mailing list. So this is an ease of use feature. There are some other uses for views we'll talk about when we get to them more formally. So I'll leave you to think about that, and I'll say bye until next time. Bye-bye.